Welcome to qnawire.
Hello everyone, so this is problem 2.39 of Griffiths. Here we have to show that for a particle in an infinite square wheel, the wave function comes back to the original form after a quantum revival time of t equals to 4me squared divided by pi h cross. So the solution for the time dependent Schrodinger equation is given by of x comma t n equals to summation over n equals to 1 to infinity cn phi n x comma t exponential e to the power minus I n squared pi squared h cross squared divided by 2m squared. These are the energy levels for nth level wave function. So you can see here the time dependent part is only the exponential part here, right? And now we need to show that phi of x comma t plus t is equals to phi of x comma t. That means the wave function comes back to the original form after a quantum interval time of capital T. So for this, what we will do, we will just put this t plus t here in this part of the time dependent Schrodinger solution here. We will write n squared pi squared h cross squared divided by 2ma squared multiplied by t. So this is the expression inside the exponential which is changing, and that's why we have written it here like this. Now substituting the value of capital T, we get divided by 2ma squared 4me squared divided by pi h cross. This is the expression for the capital T given to us. So if we just calculate this expression, we will get 2 pi n squared. Here pi cancels with this one, cross squared cancels here, e squared cancels, m cancels here, and 2 and 2 gives us 2 pi n squared. So we have the expression inside the exponential given by minus I n squared pi squared h cross squared divided by 2ma squared into t plus t is equals to e to the power minus I n squared pi squared h cross squared divided by 2ma squared into e to the power minus I 2 pi n squared. As we got that this expression into t here, this expression is actually equals to 2 pi n squared. So that's why in place of t we have written 2 pi n squared here. And so since if we need these two expressions to be same, that is the value of the wave function at t plus t, we need it to be equal to just t. So this part of the exponential should be equals to 1. So this means if phi t plus t is equals to phi t implies e to the power minus I 2 pi n squared should be equals to 1. Since we have n squared, since n is an integer, so 2 pi e to the power minus I 2 pi n squared will be equals to 1. So this is always true because n is an integer. E to the power minus I 2 pi n squared will always give us the value 1. You can explicitly evaluate this because e to the power minus I 2 pi n squared equals to cos theta cos 2 pi n squared plus I sin 2 pi n squared, and the value of the cos at this even integral value multiples of 2 pi is always equals to 1, and the value of sine at integral multiples of 2 pi is equals to 0, so it evaluates to 1. So here we are able to prove that for t equals to 4ma squared by pi h cross will always give us phi of t plus t equals to phi of t. So this proves our theorem that t is the quantum revival time. The next part of the question asks us what is the classical revival time. That means if we have a infinite square well, so a particle here, how much time will it take for the particle to go back to the original position after it bounces off first time here, then comes back there, and again comes back in this position. So how much time does it take for the particle to come back to the original position in the same state? So it takes, like you can see here, particle is going first this, then this, and then this. So if the width of the well is 2a, then if the well is a, then you can see easily that the particle covers a distance of 2a. First it goes here, then it goes completely a distance of a, and then it comes back here. So these two parts will add up to a, and this one part will add up to a. So the particle covers a distance of 2a. So if the particle velocity is v, velocity is given by distance covered by the revival time tc. That the revival time tc is given by 2a by v, which is the velocity of the particle. Now for the energy, we have the expression that classical energy E is equals to half mv squared. So here we have the value of velocity given by v equals to under root 2e by m, and that's why we can substitute in this expression, which will give us the value a into under root 2m by e. We have just substituted the expression for velocity from this expression, and we get the final answer of the classical revival time as tc equals to a under root 2m by e. Now it is asked when will be the both the revival times equal. When the classical revival time will be equal to the quantum revival time. For this, we have the quantum revival time given in the question, 4 square divided by pi h cross, and the classical revival time we just now evaluated is equal to a 2m by e. So for e equals to pi squared h cross squared divided by 8 ma squared. We just solved up this equation and we got this answer for this, which is 1/4 of the first energy level of the infinite square well. So for this value of the energy, we'll have both the quantum and the classical revival times equal. Thank you.